Okay, chapter 5.3, slopes of straight lines. Okay, slope is really important concept on straight lines. Okay, straight lines. Okay, let's see the graph on the left hand side. Okay, here is a point. Based on this point, there are two lines, the blue line and the green line. Okay, the blue line and the green line has different slope. Okay, the slope actually means slope is a slant, the level of slant. So slope is the ratio of change in the y coordinate of any 2 points on the line to the change in the x coordinate. So if we have 2 points, on one line, the change in y coordinate means the vertical distance between 2 points, and the change in the y coordinate is the difference between the x coordinates, horizontal distance. So if we see the second coordinate plane here are 2 points, x1 and x1 y1 and x2 y2. Okay, let's say this is the coordinate of this point is x1 and the y coordinate is y1. Here's the second point. The x coordinate is x2 and y coordinate is y2. So the slope is change in y over change in x. The change in y is called rise over run. Rise means the vertical distance between two. So we have 2 points and the y values are y1 and y2. The difference is y2 minus y1. The vertical distance between 2 points is y2 minus y1. And the change in x is the horizontal distance. So the difference between two x coordinates. So x1 and x2. So this is the difference this is the horizontal distance, change in x, right? This is my change in x. So this is the run part, and y2 minus y1, this is the rise part. So the slope is y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. Or you can write it like that. You can interchange 1 and 2. So y1 minus y2 over x1 minus x2. Okay, this is really important. If we start with first point, then both y and x must have the first coordinate. If you're using the second point first, then y2, then also the x coordinate must start with x2. So y2, then x2. y1, then x1. So this is a really important concept. So we used a small letter m to represent the slope, because do you remember last time the linear equation is y equals mx plus b? Okay, right? Y equals mx plus b. This is the linear equation. So in this case, x and y are variable. This is the coordinate of a point on the line. And m is what? M is the slope, right? M is the slope. And this is linear equation because the graph is linear, straight line. The graph of this linear equation is a straight line. And then the average rate of change. The average rate of change is the slope. It's always same. So any 2 points, here is a line. Let's say the graph of this linear equation is this. So let's select any 2 points. Okay, point 1 and point 2. The slope of this point 2 is same as selecting other 2 points. So slope using these two or these two or these two or these two, the slope is always the same. So we can select any 2 points. These 2 points must be different points. Select 2 different points, then the slope is always the same. So let me write here. It's a ratio of the change in the y coordinate of any 2 different points. Okay, 2 different points on the line to the change in the x coordinates. Can you see it? So it is really important to use this formula. Slope, this is the slope formula. Okay, slope formula is what? y2 minus y1 over x2 minus x1, or y1 minus y2. We're starting from 1, so x1 minus x2. Okay, so slope is rise over run. Rise over run. I will use rise over run. This is a good definition. Rise over run. Rise over run. Rise over run. Okay, so when you go rise, rise is going up or down. Okay, rise means going down as well. So if you go down, then the value of the vertical distance is negative. So we use negative. If you're going, okay, run it, okay, if you go up, rise, then the sign is positive. Okay, for the run, rise over run, the denominator is run, so x coordinate, the distance between x coordinates. If you go right, then the value is positive. If you go left, then the value, the sign of run is negative. Okay, so up, right is positive, down, left is negative. Okay, let's check this one using the example. Okay, find the slope of the line containing these 2 points, P1 and P2. So slope is what? M, right? M. The slope M is rise over run. Rise over run, right? Rise over run. So what is rise? Rise is y2 minus y1 over x2 minus x1. Run is x2 minus x1. We want to start with the second point. So by using this slope formula, y2 is 4. Okay, look at this. Okay, this is point 1, so this is x1, and this is y1. And this is the second point, so 3 is x2, 4 is y2. Okay, so we will use these coordinates. So y2 minus y1. y2 minus y1 is 4, the y coordinate of the second point, and the y coordinate of the first point. Y minus, so 4 minus y1. y1 is negative 1, so put parentheses. x2 minus x1. x2 is the x coordinate of the second point minus x coordinate of the first point, which is negative 2. Put parentheses. Okay, and then simplify each numerator and denominator. So 4 minus negative 1 is 4 plus 1 over 3 minus negative 2 is 3 plus 2. You know, negative, opposite of negative is positive, right? Minus negative means opposite of negative, so plus. Then this is equal to 5 over 7. So this is the slope. This means, you know, 5 over 7, rise over run. So rise is starting from 1 point on the graph, you go 5 units up and then 7 units to the right, because you know, the sign is all positive. The numerator is positive, negative, positive. So rise means go up, run means go to the right. Okay, let's try letter B. So the slope is rise over run, y2 minus y1 over x2 minus x1. So y2 is the second point, which is negative 2. So y value, y coordinate of the second point minus y1. y1 is 1. Okay, and then x2 minus x1, so 2 minus x1 is negative 3. Okay, and then simplify. So negative 2 minus 1 is negative 3 over, this is 2 plus 3, right? So negative 3 over 5. Or you can write it like this. This means negative moves to the front, 3 over 5. So this negative can be either numerator or denominator. So negative 3 over 5 means, negative 3 means starting from 1 point, you go 3 units where? Down. 3 units down and then 5 units to the right. Because negative 3 is negative. The numerator is negative. Numerator is rise over run, right? Rise over run. So starting from 1 point, go 3 units down because negative 3, and then 5 is positive, so 5 units to the right. All right, like this. So it looks like that. So the graph of the straight line looks like this, starting from 1 point, 3 down, and 5 to the right. Okay, so let us see. The slope is y2 minus y1. y2 is 0 minus 4 over x2, negative 1 minus negative 1. Then this is negative 4 over negative 1 plus 1, right? So that is equal to negative 4 over 0. Look at this. The denominator is 0. The denominator is 0 means it's undefined or undefined. Why is it undefined? Because undefined means we don't know, right? We don't know the value. So let's look at this. The x coordinate is, this is x1, right? x1, x2. And x1 and x2 are the same. There are 2 points, but their x values are same. Isn't it a vertical line? Isn't that a vertical line, right? Look at this. This is x, y. Here is negative 1. This is negative 1 or negative 1. So you have a 1 point over here. Here's another point, negative 1 and 0. So negative 1, 4. So sorry, negative 1. This is the second point, negative 1, 0. And let's say this is 4. So here's another one. So the first point is negative 1 and 4 is this one. The second point, P2 is negative 1, 0. So this point. So if we connect these two, then this is a vertical line, isn't it? This is a vertical line. Okay, this is the vertical line. So, do you remember holy vertex? I'm sorry, not yet. So, if the vertical line, always the vertical line, the slope of a vertical line is, remember, this is a really important concept. Slope of vertical line is what? Slope of the vertical line is 0, undefined. Slope of the vertical line is undefined. Why? Why? Because the vertical line has the same x value. Same x value. So x2 minus x1 is always 0, which means the denominator is 0. Okay? Denominator is 0. So, same x value, denominator is 0, is undefined, vertical line. Okay. Let me write it over here. Very important. Vertical line or same x coordinates. So can I just write it x1, x2? x1 and x2, same, right? And denominator is 0. Denominator, which is the run, right? Run is equal to 0. Then slope is undefined. Okay, slope is undefined. Very important concept. Okay, let's try letter D. So M is equal to y2 is 2 minus y1 over x2 minus x1. Then this is 0 over what? 0 over this minus 1. Let me write this clearly. So 4 plus 1 is 5, so 0 over 5. Okay, now the numerator is 0. What's the numerator? If the numerator is 0, then what's the value of this fraction? 0, right? 0. Okay, 0 means, okay, let's look at this. This is also a very important concept. Okay, if you graph it, let's graph these 2 points. X-axis, y-axis. Okay, negative 1, 2. Here's negative 1. Here's y equals 2. And the second point is here's 4 and y equals 2. Okay, let's connect these 2 points. Isn't this a horizontal line? Horizontal line, right? So if a line is horizontal, then the the difference between y value is 0, right? The difference between y value is 0. So rise over 1. From the rise over 1, the rise part is 0 because they have the same y values, y coordinate. So the numerator is 0, numerator is 0, so it is 0. So slope is 0. So this is also important. Horizontal line. Horizontal line indicates that the slope is 0. This is really important. Horizontal line, slope is 0. Vertical line, then slope is undefined because denominator is 0. Vertical line gives you the denominator is equal to 0 for the slope. So the slope of the vertical line is what? Undefined. Okay, so let me write it here. The slope of vertical line is undefined. The slope of horizontal line is 0. Okay. And next is problem 1. So why don't you do this on your own? I will just write the answer and the solution here. And then I will skip this part. Okay, so problem 1 is, it looks like this. Okay. Letter A and B are, just standard. Y2 minus y1 over x2 minus x1. They have values of the slope. But C and D is a special case. C is, look at this, the x coordinates are the same. X values are the same. So rise over 1. The slope is rise over 1. So the denominator is 2 minus 2 is 0. Denominators become 0. So since the fraction has denominator 0 is undefined. So the slope of this point, this line is undefined. And it has same x coordinate, right? X coordinate, then means same x coordinate. So that means it's a vertical line. So vertical line, then the slope is undefined. Since it's a vertical line, the denominator is 0. So the fraction is undefined. So that the slope is undefined. So it's really important to find out whether a line is vertical or horizontal. Vertical line, then it's undefined. Horizontal, then the slope is 0. Horizontal, 0. Vertical, undefined. Okay? All right, so, let's consider this word horizontal. Okay, we have a horizontal, the word horizontal, and it spells H-O-R-I-zontal, right? So this H, okay, let's check this H and O, the first two letters. H, we want to find the slope of horizontal line. So H is horizontal line. The slope is the second one, O, O, right? O looks like a 0, right? O looks like 0. So the slope of a horizontal line is what? 0. Okay, 0. To make it, to understand this one, not to be confused. So horizontal line, slope of horizontal line 0. So let's check the type of straight line. Okay, look at this. Here is a straight line. The right end is going up. The right end is up. And here's another one. The right end is straight. The right end is what? Going down. And then the other one is vertical line. Okay, so there are 4 types of slopes, 4 types of lines. So there are 4 types of slopes. Okay, so if you go right, then the slope M is always positive, greater than 0. This is important. So if the right end is going up, then rise over 1 is always positive. Rise is positive, 1 is positive, right? So here, let's find 2 points. Then rise is positive, 1 is positive, so the slope is positive. How about the horizontal line? Horizontal line. We know that horizontal lines, the slope is 0. The slope of horizontal line is 0. Why? Because they have the same y value, So rise is 0, 1 is certain amount. Okay, if the right end is going down, then the slope is negative. I will use less than 0. Okay, m is a number that's less than 0. This means negative. Okay, positive. Slope is positive. Slope is 0. Slope is negative, right? Negative. Okay, why is negative? Because, okay, let's go to the right. Rise over run. Okay, rise over run. Okay, rise is going down. So negative, right? Rise is negative. The run is positive. So negative, this is negative, right? Negative over positive. Negative over positive is negative, right? So that's negative. Okay, up is positive. Okay, for this slope, positive or positive is positive. So slope is positive. This one is 0 over something is positive, right? 0 over something is 0. So the straight line, horizontal line has the slope 0. Okay, now vertical line. Vertical line is undefined, right? M is undefined. Why is it undefined? Because it has the same x value. So denominator is 0. The denominator is 0. So run. So rise is 0. 0 over something. This is something over 0. This one is something over 0. So denominator is 0. So something over 0, right? So it's undefined. And the horizontal line is 0 over something. So that is 0. So let's consider like this. You are climbing a mountain. Climbing a mountain. So when you go up, slope is positive. The slant is positive. Flat surface, the slope is 0. And then going down, okay, the slope is negative. And then finally, cliff. This is a cliff. You are dead. If you jump, you are dead. It's undefined. Right? Okay, so we just compare the slopes depending on 4 types of straight lines. Okay, let's check 2 lines. Okay, 2 lines are parallel or 2 lines are perpendicular lines. So depending on these lines, let's find out the slopes, the difference between these slopes. Okay, line 1 and line 2 are parallel. Then we can write it like this. Line 1 is parallel to line 2. This is a parallel symbol. Then what happens? If and only if. If and only if, which means if line 1 and line 2 are parallel, then the slope, their slopes are the same. So slope of line 1 is equal to slope of the second line. Okay, so this is a very important concept. So 2 lines are parallel, then their slopes are the same. Or if slopes of 2 lines are the same, then 2 lines are parallel. Okay, and then here's another one. Here's the perpendicular line. So here is one straight line, line 1. And perpendicular line means it is a line that is going, passing through this line 1 with 90 degrees. Okay, 90 degrees, right angle. Okay, this is a right angle. Let's say this is line 2. Okay, right angle. Let me draw this reasonably. Okay, not like that. So line 1, let's say this is line 1. Then perpendicular line is this. Okay, this is line 2. And then these two forms a 90 degree right angle. Okay, perpendicular lines means the angle between 2 lines is 90 degrees. Okay, then let's say the slope of line 1. Let's say the slope of line 1 is m1. The slope of line 2 is m2. Okay, even this one. The slope of line 1 is m1. The slope of line 2 is m2. Okay, for the perpendicular lines. Okay, as you see, this line 1 has slope m1. Okay. L1 is perpendicular to L2. Now this is perpendicular symbol. So this means line 1 and line 2 are perpendicular. If and only if. Okay, as you see the graph of line 1, the right end is going up. So M1 is positive, right? M1 is positive. M1 is positive. But how about line 2? Line 2, the right end is going down. Do you remember? If right end is going down, then the slope is negative. So M1 and M2, they have negative, negative signs. So M2 is equal to negative, should be negative, because if M1 is positive, then M2 is the opposite of M1. So if M1 is positive, then M2 should be negative. So multiply M1 by negative, but the rise over 1 is reversed. So reciprocal, reversed. So you can write it like this. Reciprocal of M1. Okay? All right, so for example, let's say M1 is 2 over 3. Then M2 is what? M2 is negative reciprocal of M1. This means reciprocal. 1 over M1 is reciprocal, so 3 over 2. Just an example. So this will be 3 over 2. Okay, negative. Don't forget the negative sign. Now change the sign. Change the sign of the other slope. Okay, so by looking at this, if we multiply M1 and each side by M1, let's get rid of this M1 from the denominator. So we'll multiply each side of this equation by M1. Then we have M1 times M2. Isn't it equal to negative 1, right? Negative 1. Negative 1. So if two lines are perpendicular, then if we multiply the two slopes, then the result is negative 1. Okay, so look at this. 2/3 is M1 multiplied by negative 3/2, reciprocal, right? So the result is negative 1. So two lines are perpendicular. Okay, so this is a really, really important concept, formula. Two lines are parallel. Then what? Two slopes are equal. Two lines are perpendicular, then product of the slope is negative 1, or slope of 1 is negative reciprocal of the other slope. Negative reciprocal of the other slope. Opposite of reciprocal of the other slope. Okay, negative reciprocal of the other slope. Opposite of the other slope. Or negative reciprocal of the other slope. I'm sorry. Opposite of the other slope. No. Opposite of the reciprocal. Opposite of the reciprocal of the other slope. Sorry, I forgot this reciprocal. So opposite of the reciprocal of the other slope, or negative reciprocal of the other slope, if two lines are parallel. Okay, example 2, exercise 2. Okay, is the line containing these 2 points parallel to the line containing the other 2 points? Okay, so we want, so if there are two lines, line 1 has these 2 points, right? So line 1, here's line 1 and line 2. So line 1 contains 2 points, which is negative 2, 1 and negative 5, negative 1. Okay, line 2 contains these 2 points, 1, 0 and 4, 2. So using this, in order to find out whether two lines are parallel or perpendicular or neither, we have to compare the slope, right? Compare the slope. So let's find the slope of the first line. Okay, slope is rise over 1, y2 minus y1 over x2 minus x1. Okay, I will use rise over 1 again, because we have to be familiar with these words. Rise over 1, which is y2 minus y1 over x2 minus x1. So the slope of the first line, so let's find out the slope of the first line. So y2 is negative 1 minus y1 is 1 over x2 negative 5 minus x1 negative 2. Then this is negative 2 over negative 5 plus 2. So negative 2 over negative 3. Negative negative is positive, so 2/3. Okay, the slope of the first line is 2/3. And let's check line 2. Okay, if M2, the slope of the line 2 is equal to this, 2/3, then two lines are parallel, right? If M2 is negative reciprocal of M1, so negative 3 over 2, then two lines are perpendicular, right? If it is none of them, then two lines are neither perpendicular or parallel, right? Okay, so rise over 1. So rise is 2 minus 0 over 4 minus 1. So 2 over 3. Okay, 2 over 3. Look at this. We know that two lines are two slopes are equal. So since M1 and M2 are equal, two lines L1 is parallel to L2, right? So the answer is yes. Make sense? We don't have to graph it. Sometimes graph is not accurate. So it may look like parallel or not parallel. So it is better to find out the slope, exact slope, right? Exact slope. And then compare. Okay, let's try problem number 2. Please pause and then try problem number 2. Okay, so from here, let's find out the slope of the first line. So y2 minus y1 over x2 minus x1. Okay, y2 is 1 and y1 minus y1 is negative 3. Put parentheses because we want to protect the negative number. And then x2 minus x1. x2 is 7 minus negative 2. So this is 1 plus 3 over 7 plus 2. So 4 over 9. So 4 over 9 is the slope of the first line. And the second line, let's find the slope of the second line. y2 minus y1 over x2 minus x1. So 2 over negative 6. Then negative 1/3. Negative 1/3. Look at this. M1 is not equal to M2, right? Even this is not a negative reciprocal. So not parallel. Right? Not parallel. So L1 is not parallel. Not parallel to line 2. At least we know two lines are not parallel. Okay. All right, for the perpendicular, okay, what if two lines are perpendicular? How about this? This is line 1 and this is line 2. Okay, line 2. And two lines are perpendicular. So we know that the slope 1 is horizontal line. This is horizontal line, or horizontal line. So 0. Then what is the slope of the second line? Second line 2. Is it 0? Undefined. That's undefined or undefined. Why? Because it's a vertical line. Horizontal line, horizontal. So line 1 is horizontal, so that the slope is 0. And the line 2 is a vertical line. Vertical line, so that the slope is undefined. Okay, so always keep in mind this one. If you make a reciprocal, 0 over something, reciprocal is something over 0, so it's undefined, right? 0 over something, reciprocal is what? 2 over 0. This is undefined. This is 0. This is undefined. So when you make a reciprocal of 0, it's undefined. And then reciprocal of undefined, something over 0 is 0. Okay, reciprocal. All right. So negative reciprocal. So this is a special case. Okay, special case. All right. Let's try next example. Okay, example 3 is, okay, is the line containing these 2 points perpendicular to the line containing the other 2 points? Okay, here's the definition. It's asking whether two lines are perpendicular, right? Perpendicular. So if two lines are perpendicular, then what's the condition? Product of two slopes is -1, or one of the slope is negative reciprocal of the slope of the other one. So let's find the slope of two lines. So line 1 is containing 2 points, this one and this. And line 2 contains 2 points. So from each line, let's find the slope. Okay, M1, okay, slope is rise over run, y2 minus y1 over x2 minus x1. So y2 is 4 minus y1 is -2 over x2 is 4, x2 is -1 minus 3. Now I'm going to use the second point as the, the second point is the P2, right? P2. Okay, so this is equal to 4 plus 2 over -1 minus 3, so 6 over -4. Reduce it, then -3 over 2. So the slope of the first line is -3 over 2. So let's find the slope of the second line. So y2 minus y1, 3 minus 5 over x2 minus 1, 1 minus -2. Can you read it? Okay, so that is -2 over, denominator is 1 plus 2, so -2 over 3. So that means -2 over 3. All right, look at this. The slope of M2, is the reciprocal of -3 over 2, just the reciprocal. It has the same sign. So this is not so two lines are not parallel. Okay, look at this. If two lines are perpendicular, then the product must be equal to -1, right? -1. So let's check this. M1 times M2. M1 times M2 is -3 over 2 times -2 over 3 is equal to 1, right? It's equal to 1. This is not equal to -1. Right? It has to be -1. The product has to be -1. Product of two slopes must be equal to -1. Then two lines are perpendicular. So therefore, line 1 is not perpendicular to line 2. Right? Not perpendicular. Can you see it? So if two lines are perpendicular, then product of two slope has to be -1. Or one of the slope has to be opposite, different sign of the reciprocal of the other slope. So this is negative, this got to be positive. So the second line, slope of the second line is positive 2/3. Positive 2/3, then yes, they are perpendicular. But this is slope is the same. So slope is the same, so it's not perpendicular. Different slope, and then reciprocal, then it's perpendicular. Okay, try problem number 3. Okay, for this one, let's find the slope of the first line. So y2 minus y1. What we are doing is the same thing. y2 minus y1, x2 minus x1. Rise over run. So 3 minus -5 over -2 minus 4. Then 3 plus 5 over -6. 8 over -6. So -4/3. Okay, 4/3. Negative, right? Negative. Let's check M2. So y2 minus y1 over x2 minus x1. So -3 over -5 plus 1. So -3 over -4. And then negative positive. So this is positive 4/3. Look at this. Okay, 4/3 is opposite of the reciprocal of the other one. The reciprocal of M1 is -3/4, or -3/4, and change the sign. So yes, these two lines are perpendicular. So let's check whether M1 times M2 is equal to negative 1. Let's check whether this is correct. Okay, so M1 is what? Negative 4/3. M2 is 4/3. And this is equal to, oh, wait a minute, 3/4. What are you doing? I'm sorry. So this is equal to 3/4, right? 3/4. So this is equal to negative 1, right? Negative 1 is equal to negative 1. So therefore, two lines are perpendicular. Yes. Yes, two lines are perpendicular. Okay, exercise 4 is an application problem. Okay, plane is descending from a height, started to descend. It takes 30 minutes. So as time passes, the altitude of the plane is decreasing. The height is decreasing from the ground. So after 10 minutes, the plane started to descend. The height is 20,000 feet. And after 25 minutes, the height of the plane from the ground is 5,000 feet. So from this, we can find the slope. So the slope is rise over run, right? Rise over run, or y2 minus y1 over x2 minus x1, right? So let's use this one as x1, y1, and this is x2, y2. x2, y2. Okay, so just plug in these numbers. So y2 minus y1, 5,000 minus 20,000 over 25 minus 10. Then this is equal to negative 15,000 over negative 15. So this is equal to 1,000, right? 1,000. So what do I mean by 1,000? Oh, wait a minute, this is positive. I'm sorry, this is positive, right? So negative 1,000. Okay, the slope is negative 1,000. Slope is negative 1,000. Okay, slope means rise over run, right? Rise is feet. Rise indicates the feet, right? Feet. Distance. And run, what's the unit for the run? It's a minute, right? Minute. So this means, okay, negative 1,000 over 1, right? Feet over 1 minute. Make sense? So this means every minute, so the meaning of the slope means is the average of the height, the average rate of change of the height to the minute is 1,000 feet down. So the plane decreases the height. The plane decreases the height. Plane is decreasing. The plane is decreasing 1,000 feet at a rate of per minute. So decreasing at a rate of 1,000 feet per minute. Make sense? It's decreasing 1,000 feet per minute. Okay, so I think it's better. The plane is decreasing at a rate of 10,000 feet per minute. So that's what this slope means. So rise over run. Rise has a unit, run has a unit. So the slope shows the number of rise changes in the number of run changes. Okay, let's try problem 5. Okay, problem 4. Okay, if you buy a new car, then the value of the car decreases, right? So the value depreciated every year. So this one shows the value of a car, after certain years, certain years after, purchasing a new car. So when it's bought, I don't know the price of this one, but after 1 year, the value of a car is 8,650, and then after 4 years, 4 years passed, then the value of a car is $6,100. So the x-axis represents the number of years, how many years old the car is, and then the y value is the price of the car, the value of the car actually. So let's find the slope. Find the slope. So slope is y2 minus y1 over x2 minus x1. So changes in the value. So I will use x1, y1 here. Then 4 is x2, y2. So 6,100 minus 1,806. 8,000 minus 8,650 over 4 minus 1. Okay, then this is equal to 2550, right? 2550 over 3. Then this is equal to 824, so 55. This one. So the slope is 850. Slope is 850. Okay, 850 means the slope is 850. What does it mean? The unit, the numerator is the value of the car, right? Price. And the denominator, the unit for the denominator is the year, number of years. So 8,850 means $850 over 1. Over 1, the unit is year, right? Year. So 800 slope 850 means every year the value of the car decreases by $850. So the slope indicates the value of the car is decreasing or is depreciated at the rate of $850 per year. Does it make sense? So every year the value of the car depreciated $850 every year. Okay, now next definition is also important. Okay, slope-intercept form of a straight line. Slope-intercept form. We know the equation of a straight line is y equals mx plus b. So this mx plus b is the slope-intercept form. Okay, we know the equation y equals mx plus b, right? So this form is called what? Slope-intercept form. So m is the slope, b represents the y coordinate of the y-intercept. Okay, m is the slope. So if the slope is positive, then the straight line is going up. The right end is going up. And then the slope is 0. We know the line is horizontal line. And if the slope is negative, the right end is going down. And the slope is undefined if the line is vertical line, right? Okay, so y equals mx plus b. B is the y-intercept, or y-intercept. So y-intercept means it's the point where the line crosses the y-axis. Y-intercept. So you can start from this y-intercept. B, the value of the y-coordinate is b. Y-intercept, when x equals 0, y equals b. The y-coordinate is b. So b is the y-coordinate. And then slope is m. Let's say the slope is a over b. Not a over b. Let's say slope is, 2/3. Let's say this is 2/3. Just for example, slope. As an example, if the slope is 2/3, then what do we do? Okay, this is the rise, right? Rise means up or down. Run means right or left. Since both are positive, rise is positive 2 means 2 units up, right? Rise 2 units up, and then run, 1, 2, 3 run. Right? So this is the second point, so that you can graph it like this. So slope is 2 over 3 means go 2 units up and 3 units to the right. Then that point should be on the same line. It should be on the same line. Okay, so slope of 2 points is always the same. Remember, slope of any 2 points is always the same. So if slope is 2/3 in this case, if the slope is 2/3 given, then 2 up, 3 right should be the second point, and that second point should be on the same line. Okay, so using the slope and the y coordinate, y-intercept, we can find the second point. So then once you connect these 2 points, that will be the graph of the straight line. So let's try example 5. Okay, graph y equals mx plus b. This is mx plus b. So the slope of this line will be negative 2/3, right? This is the slope, and then b plus 1. So this is the y coordinate. This is the y coordinate of the y-intercept. Y coordinate of the y-intercept. Y-intercept, right? So y-intercept, so let's graph this one on a coordinate plane. Here is the x-axis and the y-axis. Okay, we are graphing this equation. Okay, the y coordinate is 1, right? 1. So let's plot the the y coordinate of the y-intercept. So y-intercept, the b value is 1. Y-intercept is 1. And then starting from this, okay, 0, -1, -2, -3. 1, 2, 3. Okay, so starting from this y-intercept, this is 2. Starting this y-intercept, let's use rise over run. So rise is, so if we rewrite this one, m is equal to, okay, let's move minus sign in the numerator, like this. So -2 is rise, 3 is run. Okay, rise is -2. So -2 means 2 units up or down. Since this is negative, down. So 1, 2 units down, and then what? Run is 3. Positive 3 means move 3 to the right. 1, 2, 3 to the right. So this is the second point. So we have the first point. The first point is given. The y-intercept is given. So that's the first point. And finding the second point is using the slope, rise over run. So rise is negative. So 2 units down and then 3 units up. 3 units to the right. Then connect. Connect these two. Then this is the graph of that equation. Or you can do this way. If you move the negative sign down, then it looks like this, right? 2 over -3. So 2 is rise, 3 is run. This means I want to move 2 units up. Okay, move 2 units up. So 1, 2 units up, and then run is -3. -3 means 3 to the left. 1, 2, 3 to the left. So that's the second point. So here's -1, -2, -3. Right? So either way, you can move this minus sign to the numerator. Either you can move the negative sign to the numerator or denominator to find the second point. Still, the result is same. Okay, then using this slope and the y-intercept, try problem. Okay, problem number 5. Let's graph this equation by using the slope and the y-intercept. So we will start from one point, which is the y-intercept. Okay, y-intercept is -1. This is mx plus b, right? mx plus b. So b is equal to -1, which means the y-intercept. The y-intercept is when x equals 0, y is -1, right? So that's the y-intercept. Y is -1. So let's start from this point using the slope. So this is the slope m. M is, okay, let's move let's move negative sign to the numerator. So negative 1 over 4. So 1 part is negative 1. Rise is negative 1. And 1 is 4. So from this point, rise is negative 1. So we will move 1 unit down. Negative means down. So 1 unit down. And then rise is 4. So move 4 units to the right. 1, 2, 3, 4. So this is just right below over here. So that's the second point, right? Okay, what if we move the negative sign to the denominator? Then it looks like this. Then rise is 1 unit up. Run is 4 units left, right? So or you can move 1 unit up and 1, 2, 3, 4 left. So 1 up, 4 to the left. So that is another point. So once you connect these two and then go to the left all the way, then this should cross, not exactly, this is not exact, right? So this line should cross this negative 4. Oh, this is not accurate. Okay, so this is negative 4, right? Negative 4. Negative 4. Let's go this way like that. Okay, so this is the graph of the equation. So it doesn't matter whether you put the negative sign to the numerator or denominator. Always, once you find 2 points and then draw the straight line, then once you move the negative sign to the denominator, and that point should be on the same line. So always, it doesn't matter. You can put the negative sign either numerator or denominator to move up or down. Doesn't matter. Okay, let's try next example. Okay, example 6. Graph this equation. Okay, this time the equation is not in the slope-intercept form. So, graphing this equation is, okay, let's first use this slope and intercept form. So rewrite. Okay, first of all, we have to rewrite in the slope intercept form, right? Slope intercept form, so that we can use slope and the y-intercept. Okay, in next chapter, we will learn a different method of graphing this type of equation. X term and y terms are in the same side. Then there is a much easier method. Okay, so anyway, we will rewrite the equation in the slope intercept form. So 2x minus 3y is equal to 6. What is the slope intercept form? Y equals mx plus b, right? Mx plus b. So this means we will solve for y. Okay, solve for y. This means solve for y. So y equals something. So from this, we will minus 2x each side. Then negative 3y is equal to negative 2x plus 6. And then what do we do next? We want y only. So divide each side by negative 3. Divided by negative 3, then y is equal to, okay, so why don't we rewrite the equation, the numerator. So separate the numerator. So negative 2x over negative 3 plus 6 over negative 3. Then y is equal to, okay, negative positive. So we have 2/3 x and then reduce it. Negative sign moves to the front, reduce it, and it is negative 2. So here is the equation in slope-intercept form. Y equals 2/3 x minus 2. So from here, the slope is 2/3, right? 2/3. This means rise is 2 units up, run is 3 units to the right. And B, the y-intercept is negative 2. So this is the y-intercept. So let's draw the horizontal axis and the y-axis, vertical axis. Okay, let's start from the y-intercept, which is negative 2. Negative 1, negative 2. Okay, and then from here, let's move 2 units. So rise is 2, right? Rise is 2, so go 2 units. And then run is 1, 2, 3. Let's say this is 3. So 1, 2, 3 to the right. Second point. and then connect these two. So this is the graph of the given equation. So if an equation is not in slope-intercept form, then solve for y so that we can rewrite the equation in slope-intercept form. Then use the first point, use the y-intercept as the first point, and then use the slope, so rise over run, to find the second point and connect. So why don't you try problem number 6? Okay, so problem 6. Did you graph it? Okay, let's check whether you are correct. Okay, x minus 2y is equal to 4. So we want to rewrite this one in slope-intercept formula. So minus x each side, then negative 2y is equal to negative x plus 4. And then divide each side by what? Negative 2, right? Negative 2, so that we have only y in the left side of the equation. So y is equal to negative x over negative 2 plus 4 over negative 2. Then rewrite it, simplify each term. Then this is equal to 1 over 2x minus 2. All right, so this one represents the slope. What's the slope? Slope is 1 over 2, right? So 1 is the unit for the rise, and then 2 is the number of units for the run. And then the slope is negative 2. So this is the slope, right? Oh, sorry, y-intercept. So this is the y-intercept. You know, y-coordinate of the y-intercept. Y-intercept. Y-intercept, in this case, y-intercept means y-coordinate. Okay, y-coordinate. So draw the vertical line, the y-axis, and then x-axis. X-axis, y-axis. Okay, let's start from negative 2. Okay, y-intercept is negative 2. The b value is negative 2. So starting from this, let's use the slope. Rise is 1 unit, so 1 unit up. We'll use a different color. Okay, 1 unit up, and then run is 2. So move 2 units to the right. 2 units to the right, so you are here. So the second point is over here, and then connect these 2 points. Is this same as the previous one? A little bit different. Okay, this is not straight. So that's the graph. Done.